friends. I wanted to go over the homework from yesterday to see how you guys did. I have posted the full solutions on Google Classroom, so feel free to go along with this. I try to show most of my work, but if there's a spot that you're stuck with, feel free to message me on Discord or send me an email. All right, so first one, here is the series that we have been given. This is an alternating series, and we have x to the 2n divided by 2n. As you saw in the video, the way that we are going to look for convergence is we are going to treat this um, as a geometric series, essentially, and we're going to be looking for the ratio. And what we know with the ratio test is if we can guarantee that this ratio is less than 1, just like a geometric series, if we can guarantee that this ratio that we're multiplying by is less than 1, we know that it is going to converge. If it's equal to 1, we know it's inconclusive, but if it's greater than 1, we know that it is going to diverge, except in one instance. All right, so when you set up the ratio test, here's what I came up with. Well, first off, since we have the absolute values, this negative means nothing. Sorry, buddy. I went ahead and left my x's in the absolute value to guarantee that that is positive. So looking at this, if I plugged in n plus 1 in for n, that ends up being 2n plus 2. Then we have divided by 2n plus 2. I went ahead and did my multiply by the reciprocal here, and then we have times 2n all over absolute value of x to the 2n. All right, here's how I like to do this. I like to go ahead and gather my n's together and gather my x's together. So if I gather my n's together, I have a 2n over a 2n plus 2. Well, that limit as we go off towards infinity approaches 1. All right, and then if I have x to the 2n plus 2 all over x to the 2n, well, those would simplify just to absolute value of x squared. And so this is what I need to guarantee is going to be less than 1. I have to make sure that this is less than 1. So I did go ahead and show my work here. Absolute value of x squared is less than 1. Well, absolute value of x squared and x squared are the same things. It does not matter if x is positive or negative. If you square it, you'll get the same term. I have x squared is less than 1. And then if I were to solve that, we end up that x squared is less than 1 in between -1 and 1. So we do have our bare bones of our interval of convergence. However, we do have two places where it equals 1. We need to test our endpoints. We need to test -1 and we need to test 1. All right, so first off, testing -1. If I were to plug in -1 in for x back up here, all I did was said, hey, what happens when x is -1? Let's go ahead and plug in -1 in for x. Well, here is what this ends up looking like. I have -1 to the n plus 1. I have -1 to the 2n all over 2n. Well, -1 to the 2n, this will always be if n is 1, n is 2, n is 3. This is always going to be even. So I have -1 to an even power. That is just going to be 1. Well, let's take a look here. I have -1 to the n plus 1 times 1 over 2 to the n, or 2n. And looking at this behaves like the harmonic series, and it's alternating. This will behave like an alternating harmonic series. So yes, this converges. And the exact same thing will happen when x is equal to 1. 1 to the 2n will just be 1. And since this is alternating, this will converge conditionally, but we'll count it. So interval of convergence, first off, we had our bare bones from -1 to 1. And since we are including our endpoints, we will have from -1 to 1 inclusive of those two endpoints. All right, second problem is a fun one. After you set up your ratio test, I'm not going to go through this whole one, but when you set up your ratio test, here is what I notice. I end up with an n plus 1, and this goes off towards infinity. So this ratio can't really be less than 1, except in one place. This could be a really, really boring series at one point, wherever we are centered. If I have this is equal to 0, we have x is equal to -1. When that is the case, this series will essentially be 0 plus 0 plus 0. If x is -1, we're repeatedly adding zeros over and over and over again. Is this a boring series? Yeah. But does it converge? Yes. So here's the deal. When you get your n terms going off towards infinity, I know it's tempting to say diverges, but there is one place where this will converge, and that is when this is equal to 0. Next one has the opposite thing. when I set up my ratio test, here's what I noticed. My n terms are approaching 0. So it doesn't matter what x is, it doesn't matter at all. Since these are approaching 0, this ratio is always going to be less than 1. So in this case, my interval of convergence is from negative infinity to positive infinity. All right, and last one. Ooh, this is another fun one. All right, so when you set up your ratio test, here's what you end up with. Our n terms are approaching 1. I have a 2n over a 2n plus 2. Those are approaching 1, and then this will be times the absolute value of x minus 3. Looking at this, this is what I need to be less than 1 in order for this entire ratio test to be less than 1. So solving this, we have absolute value of x minus 3 is less than 1. We're going from negative 1 to 1. And then I end up with the interval of convergence of 2 to 4. But we need to test our endpoints. We got to check those two out. So this is our bare bones. Let's go ahead and check those two instances where our ratio test is inconclusive. So if I have x is equal to 2, all right, well, I'm just going to plug in 2 right there. I'm going to substitute 2 in for x. So when I do this, I have 2 minus 3 to the nth power. Well, 2 minus 3, this is math I like. I have negative 1 to the nth power. And sure enough, this looks very, very similar to the first one that we had. This is going to behave like the alternating harmonic series. We have negative 1 to the n all over 2 to the n, or all over 2n. This converges by the alternating series test. But our friend number 4, it doesn't work out that way for number 4. So when I do 4 minus 3, we have 1. I have 1 to the nth power. Well, 1 to the nth power is just going to be 1. And so I have my infinite series from 1 to infinity of 1 over 2n. This diverges. This behaves like the regular harmonic series, and we know that that diverges. So here is our interval of convergence. 2 to 4, 2 and 4 are our endpoints. We are going to include 2 in the party, but we are not going to include 4 in the party. So please, 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 I went ahead and showed all of my work in these. We have one of each case. We have one where we included both of our endpoints. We've got one where it only converges where it's centered. We've got one where it converges everywhere. And then finally, we do have one where it converges at one endpoint, but not the other. So please, please, please let me know if you have any questions. I should be on Discord between 9 and 11 if you want to go over any. But hopefully this helps you with that Khan Academy exercise. Have a great day.